This video is on Unit 2, Chapter 5 on solving quadratic functions, lesson number 5, solving quadratics by completing the square. In the warm-up here, it says solving quadratics with perfect square trinomials. And the directions here tell us to solve the equations below by factoring and using the square root property. And perfect square trinomials is something that I have talked about in a couple of different sections that we've done so far in Chapter 5. And just to refresh your memory, in a perfect square trinomial, your a, x squared, has to be a perfect square. And the c has to be a perfect square. The bx that's in the middle is the square root of a x squared times the square root of c times a 2. Okay? So when I look at this number 1 that's here, it says x squared plus 14x plus 49 is equal to 4. When I look at that, x, just the left side, forget the 4 for just a second. When I look at the left side, I look at that and I automatically see that that's a perfect square trinomial. And the reason is, if you take the x squared and square root that, you get an x. Square root of 49 is a 7, and then we need that 2. So x times 7 times 2 is equal to 14x, which is exactly what our middle term is. So x squared plus 14x plus 49 is going to factor into the x and the 7, and because it needs to be a positive 14x, I'm going to leave it as a positive 7, and that's going to be a square is equal to that 4. So the left side factors into x plus 7 squared, and I'm going to leave the right side alone. Now, in lesson number 4, when we were talking about square roots, I included some examples like this. When you have a square equal to a number, we can use the square root property to complete this problem. At this point, I can square root both sides. The square root of x plus 7 squared is just x plus 7. The square root of 4 is a 2, and then don't forget your plus minus, and then we would finish this off by solving both x plus 7 is equal to 2 and x plus 7 equals negative 2. I'm going to subtract the 7. 2 minus 7 is negative 5. And negative 2 minus 7 is negative 9. So the two solutions here are a negative 5 and a negative 9. Let me show you that again on example number 2. Number 2 says x squared minus 6x plus 9 is equal to 20. Now, basically, all I'm focused on is the left side. Is the left side a perfect square trinomial so that I can solve this using square root property? Well, the square root of x squared is x. The square root of 9 is 3. And again, we need that 2. X times 3 times 2 is 6x, which is exactly what I need. I do need it to be a negative. So in order for that to be a negative, I'm going to make that a negative 3. This is going to factor into x minus 3 squared equals 20. So the left side was a perfect square trinomial. It factors into x minus 3 squared. And now I can finish this problem off by square rooting both sides. And I get x minus 3 equals a positive and negative square root of 20. Now, square root of 20 is not a perfect square. So I'm going to do the best I can here. I'm just going to simplify that radical. The square root of 20 is going to simplify into a positive and a negative 2 radical 5. Now, there's no way for me to do like I did in example 1 and set up my two equations and solve. All I'm going to do at this point is add the 3 to both sides. Now, when we write our answer here, the 3 is going to go in front of the positive and the negative. And that's your answer for number 2. 3 plus or minus 2 radical 5. Now, let's talk about what happens if the left side is not a perfect square trinomial. If it's not a perfect square trinomial, then what we can do is we can make it a perfect square trinomial. So in your notes here, it says it is possible to take any quadratic equation, create a perfect square trinomial, and solve it in a similar way. This method is called completing the square. So look at our steps here. Number 1 says to rewrite as ax squared plus bx is equal to c. You want to divide both sides by a, so it becomes x squared plus bx plus c. Complete the square by taking half of b, square it, and add it to both sides of the equation. Then we're going to factor the perfect square trinomial, and then take the square root of both sides, and that's going to create those 2 cases because the square root has both a positive and a negative value. And then lastly, solve both sides and simplify all irrational and complex answers. So let's walk through a couple of these. Example number 3, directions tell us to solve each quadratic equation below by completing the square. So when it tells me to do that, I know up front this is not a perfect square trinomial. When we look at this example, 56 is not a perfect square, so this is not a perfect square trinomial. So step number 1, let me pull this back down just a little bit. Step number 1 says to rewrite that as ax squared plus bx equals c. So in this method, your constant is going to be on the right side of the equal sign. So I'm going to subtract that 56. Now, when you write these, I want you to leave a space between your bx and your equal sign, and you'll see why here in just a second. Step number 2 says to divide both sides by a. In my example here, a is a 1, so I don't need to do that. Step number 3 says to complete the square by taking half of b, square it, and add it to both sides of the equation. So basically, y'all, what we're going to do here is we are going to make the left side a perfect square trinomial. You're going to take your b, which is a negative 18, and you're going to divide it by 2. So negative 18 divided by 2 is a negative 9. So that's part of it. Take half of b, which I just did. Now I want to square that. Negative 9 squared is a positive 81. And we're going to add that to both sides. And this is why I just said I want you to leave a little space between your bx and your equal sign so that you can add that 81 to both sides. Okay? Now, the left side is now a perfect square trinomial. It is we just forced it to be a perfect square trinomial by adding half of b and squared. Half of b squared makes that a perfect square trinomial. And what it's going to factor into is x minus the square root of 81 is 9 squared equals, and then we just need to add the negative 56 and the 81 together to get 25. Now we have a problem that looks like some of the others that we've done so far. All we need to do now is square root both sides. So we factored the perfect square trinomial in step number 4. Now in step number 5, we're taking the square root of both sides. And that's going to create our 2 cases. So the square and the square root go away. I've got x minus 9 equals a positive and a negative 5. And I'm going to finish this off by solving both of my equations. X minus 9 equals 5, and x minus 9 equals negative 5. Add the 9. 5 plus 9 is 14. And again, add the 9. Negative 5 plus 9 is a positive 4. So I have, for my 2 solutions, 4 and 14. I'm going to walk you through number 4 before we look at solutions that are irrational or imaginary. So in example number 4, it says 2x squared minus 16x equals negative 30. Notice in this one that your constant is already on the right side of the equation. Step number 2 tells you to divide both sides by a. So there is an a in this example. So I'm going to divide every term in here by a 2. So I get x squared minus 8x. I'm going to leave a little space equals negative 15. Now, once we've done that, step number 3 says to complete the square by taking half of b, square it, and add it to both sides of the equation. So this is where we're creating that perfect square trinomial on the left. b is a negative 8. So negative 8 divided by 2 equals negative 4, and then we need to square that and get 16. So we're going to add 16 on both sides. Okay. Now, at that point, what we want to do is factor the left side. So the left side is now a perfect square trinomial. We made it a perfect square trinomial. And it's going to factor into square root of x squared is x, square root of 16 is 4, and then keep that sign on the b. And then negative 15 plus 16 is a positive 1. And then at that point, all we need to do is square root both sides and finish this off. So we get x minus 4 equals a positive and a negative 1. Separate your two equations and solve. We're going to add 4. 1 plus 4 is 5. And then again, adding 4. Negative 1 plus 4 is 3. So I have a 3 and a 5 for number 4. Let's look at number 7. Number 7 says x squared plus 16x minus 21 is equal to negative 5. The first step is to get your constant on the right. Now, this problem has 2 of them. So we're going to add that 21 to the right side and combine it with the negative 5 so it goes away on the left side. So I got x squared plus 16x equals negative 5 plus 21 is a positive 16. Okay, so from here, again, you're going to complete the square on the left. To complete the square on the left, it's b over 2 squared. So 16 over 2 is 8 squared is 64, and that's what we're going to add to both sides of our equation. So add 64, add 64. Factor the left. Again, y'all, what you have done is you have forced that left side to be a perfect square trinomial. When you have a perfect square trinomial, it factors into the square root of the x squared is x, the square root of 64 is 8. The sign on the b matches squared. Equals 16 plus 64 is 80. Now we have to square root both sides. And we get x plus 8 equals a positive and a negative. The square root of 80. We got to simplify. 80 is 16. I feel like we just did this 16 and 5. So that's going to give me 4 radical 5. Now, we cannot really break this apart into our two equations because 4 radical 5 is irrational. I'm not going to come down to a nice rational integer answer. What we're going to do is we're just going to go ahead and minus that 8. And again, it goes in front of the plus minus. So there's your answer on number 7. Let's look at number 10. Number 10 says 4x squared plus 76 is equal to 16x. So the bx is on the wrong side and the constant is on the wrong side. So I'm going to subtract the 16x, and it needs to be over here with the 4x squared. And then we're going to subtract the 76 to take it away from the left side. Negative 76. So I've got my constant on the right. I need to get rid of the 4 that's on the x squared. Completing the square is not going to work unless that leading coefficient is a 1. So I have x squared minus 4x equals negative 76 divided by 4 is going to be a negative 19. Okay, so at this point, we're going to try to complete the square. So that's b over 2 squared. Negative 4 divided by 2 is negative 2. Squared is 4. So we're going to add 4 to both sides. The left side, again, is a perfect square trinomial. And if you think back to that lesson, let me just go through this really slow here. The reason why this is a perfect square trinomial and the reason why it factors the way that it does is because in a perfect square trinomial, the first term is a perfect square. The square root of x squared is x. Square root of the constant is a 2, and then we have to multiply it by a 2. So that gives me 4x, which is exactly what that b term is. Now, the b is a negative, and in order to have a negative, it needs to be x minus 2. So this is going to factor into the x minus 2 squared. So the sign on the b is always going to match the sign in your factor. And then negative 19 plus 4 is going to be negative 15. So at this point, we have factored the perfect square trinomial. The next step is to square root both sides. And we get x minus 2 is equal to a positive and a negative. Now, when we try to take the square root of negative 15, obviously there's a negative underneath that's going to create an I. But 15, the square root of 15 is not going to reduce. So now what we need to do, the last step here is to add the 2 to the other side. And again, that goes in front of the plus minus. So there's our answer on example number 10. So those are your notes for chapter 5, lesson number 5 on solving quadratics by completing the square.